Hello everyone, and welcome to the triangle inequality theorem. Please copy this down on blank paper. The triangle inequality theorem states that the sum of the two smaller sides of a triangle must always be greater than the third. So please write that down. I'll give you a second to copy that. The sum of the two smaller sides of a triangle must always be greater than the third. We're going to take a look at one of my examples here. And what it says is the following. A triangle with sides 5, 5, and 10 would collapse. So let's think about that for a second. If this was 5 here, and this was 5, and this was 10, when I went to go make my triangle, and I put a 5 here, and a 5 here, and a 10 there, the triangle would have no angle measure right here, and no angle measure right here. It would in essence just be two lines, one on top of the other. So the triangle would collapse if the two sides were 5, 5, and 10. If one of the sides was a little bit longer than 5, and we were to have an example of longer sides, for example, if one side was 7 and another side was 5, the last side could in fact be 10 if we wanted it to be, because the sum of the two smaller sides, in this case 7 plus 5, is greater than 10. So, in essence, the sum of the two smaller sides of the triangle must always be greater than the third. Okay, we're going to take a look at another example, and I'm just going to move this up. So, sometimes you are given questions like the following. Could the lengths of 4, 7, and 13 make a triangle? So what you want to do is you want to find your smaller sides, which in this case are 4 and 7, and you're going to add them together. 4 plus 7 equals 11, and then you're going to compare it to the 11, the 11 to the 13. Is 11 greater than 13? No. So you could not make a triangle. Okay. Another example, could the lengths of 8, 7, and 13 make a triangle? So I'm going to do 8 plus 7, which is 15, and I'm going to compare that to 13, and the answer would be yes, because the sum of the two smaller sides is greater than the third. Now, the last question a lot of kids get wrong, so be careful with this. Most kids would think, oh, let me just add 13 plus 5, which is 18, and 18 is greater than 8, but that would be incorrect. You want to find the two smaller sides of the triangle, which in this case are the 5 and the 8. You need to add those together. 5 plus 8 is 13. And 13 greater than 13? The answer is no. So you could not make a triangle with side lengths 5, 8, and 13. Okay, next page we're going to go to. So do not get confused with right triangles. If I wanted to know if something made a right triangle, you'd actually have to use the Pythagorean theorem of 5, 12, 13. And in this case, you would do 5 squared plus 12 squared equals 13 squared. Now, I'm sure you all know that this is already a triplet, so the answer is yes. Now, the last type of question that you'll get is a little confusing. It says, given the side lengths of 5 and 2, what could the third side be to make a triangle? So what I need you to do is take a moment and copy this chart down for me, please. And the chart is going to look like this. So copy this chart, and then we're going to take a look at it. I'm going to pause the video. Okay, in this case, we are going to do 2 plus 1 is greater than 5, and the answer is no. So we cannot make a triangle. 2 plus 2 greater than 5. No, cannot make a triangle. 2 plus 3 greater than 5. Now that's very, very close. 5 is equal to 5, but 5 is not greater than 5. So the answer is no. Then we're going to go 2 plus 4 greater than 5, and that's a yes. Then we're going to do 2 plus 5 greater than 5. That's a yes. 2 plus 6 greater, or 2 plus 5 greater than 6. That's a yes. 2 plus 5 greater than 6. That's a yes. Then I'm going to do 2 plus 5 greater than 7. Oops, no, equal to 7. 2 plus 5 greater than 8. No. And 2 plus 5 greater than 9. No. Now, if you take a close look here, it's these lengths that would work to make a triangle. And in essence, what it winds up to be is between 3 and 7 non-inclusive. So, for example, if we looked at an example of, let's say, 3.1, 2 plus 3.1 is greater than 5, that's a yes. We could also look at an example like 2 plus 6.9 greater than 7, and that's a yes. Now, the easiest way to remember this is there is a formula that works for this when you are given two side lengths, and it looks. Try to remember that it's always greater than the difference and less than the sum. So the last side would have to be greater than 3 and less than 7. Greater than 3 and less than 7. So remember, we were originally given side lengths 2 and 5. So you could do 5 minus 2 to get 3, and 5 plus 2 to get 7. And now you have to know that it's greater than 3 and less than 7. The way that we write this with an inequality would be the following. 3 less than x less than 7. So this represents all the numbers that are greater than 3, which is the difference, and less than 7, which in this case is the sum. All right, we'll take a look at this again in class, and I'll see you soon. Thanks.